Welcome to compound interest. Does anyone have any interest in interest? Very few banks today pay interest based on the simple interest formula. Instead, they pay interest by using a principle called compounding. The difference between simple and compound interest is this: simple interest grows slowly, compounding speeds up the process. How does it work? Simple interest is interest on only the principal amount. Compound interest is when your principal and any earned interest both earn interest. Let's take a look at these two examples. Consider this example. You begin with $100 invested at 10% at annual interest. So after 1 year, both the simple interest and the compound interest earn $10. Notice though, in year two, they both also the simple interest earns another $10. However, your compound interest has earned $11. You may say, well, that's just $1 more. And then in the third year, this one has earned 13 more dollars. In the fourth year, you have earned 16 more dollars. Okay, so it's actually 6 more dollars. But then in the fifth year, notice it's year 150. Now you have earned, um, the compound interest has earned $21 over the year. Okay, so in 10 years, you're up to $59. In 20 years, look how much. You're over 300, you're 372 more. Okay, and if you go over 50 years, notice that you're at 11,739. Okay, and that was only starting with a $100 investment. Okay, so compound interest wins. From this example, it is easy to see that if you're saving money, you would prefer compound interest. Let's talk about the story of Ben and Arthur, the importance of compound interest. Ben and Arthur are close friends. Ben starts investing at the age of 19, and for 8 years he invests $2,000 annually in investments, and it earns him a 12% in compound interest every year. By the age 26, Ben stops placing any more funds into his investments, so in total he's only invested $16,000. Arthur starts investing at age 27. He puts in $2,000 each year in his investment fund that again earns him an annual interest of 12%. However, unlike Ben, Arthur continues to invest even after he has reached the retirement age of 60 plus years. In total, Arthur invests $78,000 over a period of 38 years, while Ben invests a total of $16,000 over a period of 8 years. Now, who do you think ended up with the larger portfolio by the time they were each 66? Okay, let's take a look at what happened just in the first 40 years. So here's Ben's investments, and remember, it was only $16,000 over 8 years. Okay, so it was 8 years. Arthur did not invest the first 8 years, but he started placing 2,000 in at each time. Notice that Ben's money, by the time 40 years are done, he is already up to $134,646, while Ben is only at $72,559. Now then, let's look at the last 25 years. So at age 65, notice that Arthur has over $1.5 million, but notice that Ben is over $2 million. and Ben didn't put in as much as Arthur did. Okay? Calculate compound interest uses this formula. A is going to be the total amount. P is standing for the principal, in other words, the initial amount that you put in. R is the interest rate. And N is the number of compounding periods. And this is something new that's different than the exponential growth and decay. T is time in years. Number of compounding periods. Notice that the number of compounding periods N is a new complication. Now, there are many different ways of compounding. So you could do compounded yearly for 6 years, where N is equal to 1. You could do compounded monthly for like 6 years. In this case, N would be equal to 12, 1 for each month. What about compounded quarterly for 6 years? Well, how many quarters are in the year? That's right, there are 4 quarters in a year. Compounded daily for 6 years. Notice that your N is 365 for each day of the year. Compounded daily for 6 months, that means that for each month you have 30 days. All right, let's take a look at this example. $100 is invested at 10% interest compounded yearly for 6 years. So here's our formula, where A is equal to the principal times our rate of 1 plus the rate divided by the number of compounding periods. But notice your exponent is the compounded periods times your time. So in this case, because we are compounded yearly or annually for 6 years, that means that wherever there's an N, we just put in a 1. Notice that the change in the compound interest formula from the exponential growth formula is in the compounding period N. It divides the rate by compounding period and multiplies the time by the compounding period. So when we put our numbers in, like the $100 is your principal, so it's in front. Our rate was 10%, so that's 0.10. So 1 plus 0.10 is 1.10. And then we have 1 times 6 for 6. And so in 6 years, you will, off of the investment of 100, you will get $177.16. So if you're compounding yearly, or another word for yearly is annually, your formula is just the exponential growth equation because the 1 does nothing to help your investment. Let's take a look at if we invest $250 and we're investing it at 6.5% for 8 years, but this time we're compounded monthly. Okay, still using our compound interest formula. Notice that the compound period N is equal to 12, representing each month of the year. We're going to place 12 in where the N's are. Our percentage has to be changed to a decimal, 0.065, and T is 8 years. And our principal that we're starting with is $250. Well, once we divide 0.065 by 12, we get 0.0054. You may say, man, that's an awfully small number. But then notice if we take 12 times 8, we have an exponent of 96. So in 8 years, your $250 investment will become $419.92. So even though you divide your rate by 12, because you multiply the exponent by 12, this is the power of the compounding period. Okay. Here we have $25,000 at 8% for 3 years compounded quarterly. So how many quarters are there in each year? Yes, that's right. There are 4 quarters in each year. So again, notice that even though you're dividing your 8% by 4, because you're multiplying the 3 years by 4, your exponent turns into 12. All right, another example. Here we have $1,500 at 4.5% for 2 years compounded monthly. Remember, there are 12 months in a year, so the compounding period is, that's right, 12. So again, notice that even though you're dividing your 4.5% by 12, because you're multiplying 12 by 2, that your exponent would be 24. So you would make more money. Thank you for participating, and that's it.